Hey, I'm back. Um, Happy Thursday. I wanted to show you my approach for solving absolute value inequalities. Talk a little bit about checking your work here because all that's a little challenging. Okay, first of all, an absolute value, from my perspective, has something similar to a square root radical equation, which is that you want to isolate the absolute value first. Okay. So in other words, I would need to get this 5 away from this. 2x minus 3 is less than 12. Okay. So once you've isolated the absolute value, then you can branch it, right? There's going to be two branches. The positive branch where nothing changes. That's the easy one that people always get right. And then there's the negative branch, and the negative branch is like multiplying everything by -1. And the reason I say that is to remind you that this sign also changes. Is there a way that I could change my color so I could highlight this? This is the important part. Bingo, stars, hearts, I don't know. Right here, right here. Um, it's just super easy to forget because you start with absolute value equations, and then all that matters is that the number changes sign. But in the inequality, you have a comparison, and the comparison switches too. So we can talk more about that if you're interested. But from here, then it should be pretty straightforward. You have 2x is less than 15, and you have 2x is greater than -9. And then you're dividing by 2, so x is less than, well, whatever, I'm just going to leave it as 15 halves because it doesn't bother me. And then x is greater than -9 halves. Okay. So just in terms of the pictures, because I always like to go to pictures here with inequalities, this is a statement. Here's 0, here's -9 halves. I'm saying that x should be bigger than that thing. Okay? And I have this other statement over here, which is slightly conflicting, and I have 0, and I have 15 halves, so that's like over here, and I'm saying that x should be less than all of that. Okay, so that's interesting. So how do I put these two things together? Well, first of all, it really matters whether this is an and or an or statement, because if this was an or statement, my answer would be all real numbers, because saying, well, it could be bigger than this, but it could also be smaller than this, that's an or statement. And basically then all real numbers are solutions, because all real numbers are either make this true or they make this true. There's no single real number out there that does not make one of these two things true. Take 0, for example. Well, it makes this one true and it makes this one true. Take -100. Well, it doesn't make this one true, but it definitely makes this one true. So there's this kind of implicit thing that happens with absolute value and inequalities, which is that a less than, right? If you have the absolute value less than, you're creating kind of a little boundary where things have to exist in between, which means that's an and statement. But if you have the absolute value is greater than, then that's creating this kind of two branch approach where it's like, well, it's got to be outside of this, and it could be this side or this side. That's an or statement. So there's this implicit meaning of the absolute value when it's put together with the inequality, which is a little bit tricky. I don't know how deeply the videos of the text kind of hit this part. But anyways, this is an and statement because it's the absolute value is less than, so that's the first case. And so we have some going from -9 halves up to 15 halves is my kind of solution zone. So in other words, if I go to interval notation, x has to be something that's bigger than -9 halves, but less than 15 halves. So that would be my solution in interval notation. So the check is actually pretty involved here. We would need to check the boundaries. And by boundaries, I mean the -9/2 and the 15/2. Then we would need to check a solution. So that would be a number like 3 or -2. And then if I really want to be thorough, something that's not a solution. And so I would say something like -5 or 10. Why do I have to do all of this extra work? Because the inequality is by its nature something with multiple solutions. And so just checking one thing doesn't really prove anything. We have to really be more thorough about what works and what doesn't work. So I'm going to leave that there. The check, of course, is just sticking numbers into the original equation, but lots to think about in terms of solving those types of problems. You can also not think that heavily about it and just get good at it. All right. See you guys later.